7.3, we're going to be learning proportions and triangles, and this is kind of a complicated section. It will be part of that. Yeah. So, let's go ahead and get started. I have a little review that I want to show you here in a little bit, and I'll go to Math Antics for that. He has a pretty cool video that reviews proportions. So let's get started. 7.3. So we skipped over chapter 6, I think, and chapter 6 would have taught us about similarity. And so one of the ideas of similarity is proportions. So like I said, we're going to have to figure that out. So our goal today, students will be able to calculate height of a right triangle. How can you find the length of the altitude to the hypotenuse of a right triangle? Okay, interesting. Yeah, we have to do. Okay, so before we get going into this too far, I want to review proportions. So let's watch this. Pause this because I don't think the Camtasia video needs this. Okay, so we're going to resume now with the lesson now, and we have a new theorem. No. Okay, so this is a tricky diagram here for some students, and the problems that we're going to have are going to be a little bit tricky. So this theorem says if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So there's a symbol that we use in geometry that means similar, and I just had it there. Let's see if I can get my pen to work. This symbol means similar. Okay, now when we say that something's similar, there's a couple ideas we need to know. One, the sides will be proportional. So that's how that last video is going to help us. We're going to be setting up proportions. And so anyhow, notice that there's three triangles in here. You have the big triangle, that is this black one. And it is a right triangle. There's the right triangle. Now, the altitude that's created in the big triangle creates two smaller ones. This one here and this one over here. They're also right triangles. Here's the red one, and then here's the blue one. That's the smaller one. Now, all three of these triangles will be proportional. So, in order to solve for heights or sides and so on and so forth, we're going to have to set up proportions. So I want to do some examples and help you with this. We'll go through this fairly slow because a lot of people really stink at doing this. So not the easiest problems to deal with. So let's do this problem now. It says identify the similar triangles, then find the value of x. So we're after this one right here. Okay, so I'm going to make a recommendation on all of these problems. All of these problems. Always make three triangles. Make three triangles. Now, the three triangles I'm going to make is one large one, one medium one, and a small one. Okay, so I'm going to make my first right triangle like this one. So this is my big one right here. There's my big one in black, and I recommend that you do the same thing. And so there's my right triangle. Now I'm going to make one that's a medium size. Go in the same direction. Okay. And then I make a third one. That's going to represent this one over here. But I make it the same direction and make it a little bit smaller. So I start off with a large triangle, a medium, and then a small. Now, the tricky part on setting up these proportions is putting in the information where they belong on these three triangles. You see, so take a look. This long side is 5, so that goes here. Everybody good with that? And this side over here is 3. That one's obvious. Okay. And the bottom's 4. Okay. Now, let's talk about this triangle here now. There's a right angle right here also, right? So where does this 4 go on the medium triangle? You see, this is where it's tricky, isn't it? Some people are saying the bottom, some are saying over here. Remember, this is the right angle, and it's always opposite of the right angle is the hypotenuse. So that means if you go opposite over here, the 4 goes here. Okay? Now the question is then, where does this x go? This x, it's the height from here to here, right? So I think the 3, hold up. You see this 3 here? This 3 is part of the big triangle, right? Is it part of the medium triangle here? So this 3 doesn't go here, so the x, we're going to say, goes here. Right? Does that look right? Now, by the way, this triangle over here I'll do in blue so we can see what's going on here. That's this one over here, right? And so where does this 3 go? This is on opposite of the hypotenuse, opposite of the right angle. So the 3 goes here. And where does, now this side here, it has the length x, right? Now, that x is the long side of, well, it's the medium. This is the longest side. That's the hypotenuse. This is one of the legs, but this is the longer leg. This is the shorter leg over here. So that x goes here. Okay? You see what I've done? This step that I just did is a little bit tricky. Okay? Once you do this step, then your job is to set up a proportion. And all you need to know is that the sides are proportional. And just like we saw in the video, you have to set up the proportion equally. Like if you do, remember we did books per day? Well, you got to set up the proportion the same way each time. And so let's look at a proportion. Now the nice thing about having things set up this way, I can see which sides are proportional. The 5 is proportional to this 4, and this 3 is proportional to x. Does that sort of make sense? So what I do here is I'm going to set up, there's multiple ways to set this up, but I'm going to do big triangle on top, big triangle, and then on the bottom I'm going to put medium triangle. Triangle. Okay, so if I take the hypotenuse of the big triangle, I put it here, 4 is the hypotenuse of the medium triangle. Does that make sense? So I say 5 is to 4. 5 is to 4. Now I take this side. I could take this side, which is the small side of this big triangle. It's the smallest leg. And this side matches up with that one. Does that make sense? So I'm going to use the big triangle again. The big triangle goes over here. Big triangle goes on top. Medium goes on the bottom. And so in this case, I'm going to put 3 is to x. And once you set up the proportion, it's an easy problem. You can just cross multiply and get x. So let me give myself some room by erasing some stuff. And now we will solve this proportion. All right. So cross multiply this way, I get 5x. Cross multiply this way, I get 12. Okay? And then what do? I just simply divide by 5 on both sides. I'm using some basic algebra now. And so, get my pen going here. Divide by 5. Divide by 5 here. I get x is equal to, let's see, 5 goes in there twice. and then as I think it's 2.4. If you use your calculator, 2.4, did you get that? Yeah. Okay, so these problems are kind of tricky. And so the first step, again, is to draw the 3 triangles, then put in the information. So let's try this one more time. On this problem over here, I'm going to draw the 3 triangles again. I'm going to start off with this big one, and I think I'll write it right here. There's the big triangle. It's right here. Okay. Then I'm going to draw a medium triangle. There's my medium one. And then a smaller one. Okay. They're all 3 right triangles, excuse me. And again, the next task is to put in the information where it belongs. Well, the big one's easy because it has all the information on it. You see, so 13 goes here. That's this one. The 5 goes over here. And then the 12. That one was easy, right? Okay, well now the medium triangle is this one, and it's kind of like upside down in comparison to this one. This one was like right side up. The right angle over here now is up on top. And so what you have to do is make sure you put the numbers in the correct spots. For example, what is this length right here, from here to here? Do we know that length? We don't know that length. And that's this length from here to here. We do know this 12 though. Where does the 12 go? It goes on the top because again, it's opposite of the right angle. So if I go opposite of the right angle here, that would place the 12 right here. Yeah. Esmeralda? No? Yeah, sorry. All right, so now we need to figure out where the x goes. Well, the x is the shortest side of this black triangle. So the x actually goes here. Does that make sense? Now let's move on to this triangle. The hypotenuse is over here. So that means the hypotenuse over here should be 5. And then on this small triangle, where should the x go? The x right here. I mean, you have 3 sides. 1, 2, 3, right? We figured out the hypotenuse, so the x either has to go here or here, right? But don't you notice the small triangle? Let's bury it again. It has a short side, a medium side, and the hypotenuse. So it's on the medium side, isn't it? So that means the x has to go here. Okay? This is pretty easy to make a mistake here. But in any event, since all 3 of these triangles are symmetric, we can set up a proportion again. So again, the key to setting up a proportion is to set it up the same way each time. Now I like to go ahead and go with big triangle again and then medium triangle. So I'm going to go with the big triangle, and then I'm going to go with the medium triangle. But keep in mind, there's other ways to do the proportions. You could go medium to small if you want. You can even do small to this large triangle, as long as you set it up the same on both triangles. So anyhow, this side matches up with this one, so I'm going to put 13 is to 12. And then let's see, I got to get the x in the equation somehow. So now I'm going to use the big triangle again. I'm going to say this one matches up with that one. So 5 is to x. Okay? Once you get this set up, it's pretty easy. You just use some basic algebra. So we cross multiply here, cross multiply here. I get 13 times x is equal to 12 times 5, which I think is 60. Then divide by 13 here. Divide by 13 here. Can someone do this in their calculator? What do we get? 4.615. That's probably good enough. Okay. You get the idea, right? So I'm going to stop right now at the moment and let you do a couple problems on your study guide, okay? And then we'll come back and do the second part if I have time. Okay, I'm going to pause it right here. How about if we do that after school? Okay, so we're going to learn one more proportion that you can use with these types of triangles. Okay, so let's take a look. The new type of proportion. Whoa, back up. This one. This is called the geometric mean. And I have to be honest, this one kind of confuses me because I always like to draw out my three triangles and then I set up proportions. So I'd like to kind of show you how this one works. Okay, so here's what happens. When we draw this altitude in here, like this one, this is what we call the height of something. Altitude we often refer to in an airplane as the height that the airplane is at in the sky, right? Well, in this case, it's the height of the triangle. If you were to measure the height, you just go straight down, right? Well, altitude always makes a right angle like this with the base. Now, think about this for a moment. I'm going to erase there a little bit. As this altitude comes down and hits this base, it splits the base into two spots. You see this spot and this spot. Make sense? The altitude comes down and it hits that spot right there. Then you got two smaller pieces. The base was originally bigger. The base was originally like AB, but now it's BD and AD. Well, you can set up a proportion where the altitude is in these spots. You see that? They're on the diagonal. And then the two smaller pieces go here or here. It doesn't matter which way you do it. The two smaller pieces, this one and this one, go here and here. When you set up a proportion that way, it's called the geometric mean. I have to admit, I don't really care to use this one that much. I try to use the other one. But this is another proportion you can use, and it does work. So we're going to do an example where we use what's called the geometric mean. The key to doing the geometric mean is this diagonal one. Notice it's the same number in both spots here. The numbers that are on this diagonal is the altitude. This one right here, whatever this one is. Okay, so let's see if we can do that. We'll do an example real quick. And this one. Okay, see, so notice what happens. What we want to do is set up a proportion. So I'm going to set up a proportion like I normally do. Right here, right here. Now, this one and this one, they're the one, that's the altitude. Where's the altitude on this triangle drawn? Hopefully you got it figured out. It's the 8.5. See, so notice this way, this altitude goes this way, and it hits this one right here, right there. Okay? And so the 8.5 goes here, the 8.5 goes here. Okay? Those two are the ones that are the same. You guys got it? I'm recording, okay? Okay, come on, Enrique. All right, now these two pieces take up these two spots here. And it doesn't really matter which way you do it. So I'm going to put W on one of them, and I'm going to put the 5 on the other one. And now you solve this proportion just as before. Okay? So I would cross multiply this way. I get 5W is equal to 8.5 times 8.5. That's 8.5 times 8.5. And this is getting a little confusing with all these dots in here, right? So sometimes maybe it's better to use parentheses. Okay? So someone with their calculator, multiply 8.5 times 8.5 for me, please. What? It should be 60. 60. What is it? 72.25 is equal to 5W. the 5W is equal to 72.25. Sometimes I can see it just fine on my screen. And you guys can't see it as well. Okay, but, you know, we're going to divide by 5 now on this side, divide by 5 on this side. So W is equal to 0.45. You see how easy this is? So one of the other ways we can do these triangles and solve for the heights and stuff is by setting up the geometric mean proportion, like this problem here. So what I'd like you to do now, I'd like you to go